Well, you have to write the other stuff. So today we're just going to graph these, which means the notes are really short, but the problems take a lot of steps here. On your homework, it says follow the 6 steps on page 333 to analyze the graph. We're only going to do 5 steps because we're skipping the same step of yesterday of looking at what happens around the x-intercept. So on your homework, it says follow 6 steps. You're just going to follow these 5 steps. In behavior, we did that already. X and y intercepts. How do we find x and y intercepts again? You just plug in 0 for the other one, right? So to find x-intercepts, you make y equals 0. To find y-intercept, you make x equals 0. This we did. Determine the zeros, the multiplicity, and does it touch or does it cross. Determine the max number of turning points. We did that already. And then step 5 says, put this all together to make a graph. And I added, you might need to make a little XY chart, but it's still going to be shorter than if we didn't do all these other steps. Okay, so I know you did this in Algebra 2, and we did this in pre-calculus for those of you that took pre-calculus. So let's just jump in here and have some fun. The bad part about these is sometimes you get really weird y values, and your y-axis is probably not going to go by 1s on most of your problems. So you're going to have to get all this information and then determine, do I want my y-axis to go by 5s? Does maybe need to go by 10s to get the points on there that you need? So I think let's just go in order. Step 1, they said do the end behavior. What degree would this function be? 3, because this is x squared and this is x, so this would be like, if I multiplied out the first term, it would be 2x to the third. So it would be odd, and it's positive. So I'm going to write this 5 steps, and I'm going to say my end behavior is as x goes to infinity, f of x goes to something, and as x goes to negative infinity, f of x goes to something. If it's odd and it's a positive coefficient, which way is it going to go there? You know yet? Does that know that? Well, I think I wrote mine backwards from you. I wrote infinity first. If you write negative infinity first, you're just wrong then. I always remember if it's odd and it's positive, positive stays positive, negative stays negative. So positive stays positive, negative stays negative. So the positive side goes up, the negative side goes down. Step 2, x and y intercepts. Really, step 2 and step 3 are kind of almost the same in terms of x-intercepts, because the x-intercept is the same as the 0. Do you agree with me on that? So the great thing about finding the x-intercepts is if you just set this equal to 0, right, they're just your zeros. They're great because they're already factored out for you. So you get, there's an x-intercept at negative 1/2, because you subtract 1 divided by 2, and there's an x-intercept at 3. The y-intercept we haven't been finding, but it is a pretty easy point to find because you just plug in 0 for x, and you can just use your calculator that you love so much. So the y-intercept would be f of 0 when you plug 0 in. So I'm going to get 2 times 0 plus 1 times 0 minus 3 squared, which is what? 1 times 9, which is 9. It's times. I'm plugging in 0 for x. Step 3, find all of our zeros, multiplicity, blah, 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 like we did yesterday. I feel like I need to double tape this so I can see these steps. It's so hot right here. It's actually getting really warm this room. It's like right here, not so hot. I said right here, it's like summer. Step 3, find what we did yesterday. So step 3, I already know my zeros are x equals negative 1/2 and x equals 3. Multiplicity is the power there. There's only a power 1, so that's a multiplicity of 1 and a multiplicity of 2. Odd multiplicity crosses. Even multiplicity touches. If you did your homework yesterday, that's exactly what we did on our homework yesterday. Hooray! And we get to graph it. Hooray! points? We already said the degree was 3, so how many turning points could this graph have? At most 2. It might not have 2, but at most 2. And then step 5 isn't really something to do except for to make a graph. Multiplicity, that's what we did yesterday. Multiplicity, it just says mult, but it stands for multiplicity. It's just, the multiplicity is 2. Here's some notes. They're not written on though because Taylor was absent yesterday and she took the written on ones that I had turned it on for you. Maybe you can get them later for you. She reminded me. Or they're online. So put it all together to make a graph. So let's make a graph. Well, maybe I don't know. Let's just make a graph. You don't have so much room like I do, right? Your x-axis should really always go by ones, but your y-axis is never going to go by ones, probably on these. 9's not too far away, but I say we just go by 2s at least. But I'm just going to go to like 4 on this. 1, 2, 3, 4. You need to make sure that you show me what your graph is going by because the scale is going to be different. If you don't label it, then I grade it as it's going by ones. So make sure that your y-axis, you show me. I always say like just label a couple points, or some people write at the top like by 10s, by 20s. This just says 9, so maybe it's not going to be too bad. We'll see. So I'm just going to go by 2s here, right? So I'm going to go 2, 4, 6, 8, 10, 12. So I'm just going to put 2, 4. And if you just do that, that tells me it's going by 2s and you don't have to label anything else. And here's why we do all these steps, because it makes graphing this a little bit easier than if you just started randomly picking points and hoping that you got the right graph. Start with your zeros. You are going to have a 0 at -1/2 and at +3. Yes? Do you agree with me on that? We know any other points on this graph right now? We know the y-intercept is 9, so I can go up here to 2, 4, 6, 8, 9. And we also know some other things. We know the end behavior. We know that the negative side should go down and the positive side should go up. You agree with me on that? So like you don't have to pick any points outside of those zeros because you know the end behavior says that this should go down and this should go up. We might have to change it at some point, so we don't draw that in yet. But we know that part. We also know that this one crosses, so we could even say we know that this is going to go up to 9 and cross like that. We don't really know what's happening in this area yet, but at 3, we know it's going to come down and just touch and go back up. Agree with me on that? That's why we do all those steps. But we don't know what's happening here, which is where we might need to pick a couple points. And so that's why I said you may need to pick a few points in between the zeros. And I don't think it would be a bad idea to pick both 1 and 2 here to see, does this keep going? When does it turn and come back? So step 5 is where I would make a little XY chart, and I'm going to say, let's pick 1 and 2, and they might be like crazy big numbers, but at least to see what's happening. And you're welcome to just use a calculator. I'm going to do my math. 1's not too bad to do. If I plug 1 in there, I'm going to get 2 plus 1, which is 3, and 1 minus 3 is -2 squared, which is 4, which I think gives me a value of 12. Do you agree with me on that? Which means before you make your graph on some of these, you might want to pick your points. Like you might say, oh, I need to pick the points in between, because that might change how you label your graph. If I plug 2 in there, I'm going to get 2 times 2 is 4 plus 1, which is 5. And 2 minus 3 is -1 squared, which is 1. Oh, so that's just 5. So let's see. 2, 4, 6, 8, 10, 12. Look at that. I didn't even know, and I went up to 12. Genius. And if I plug 2 in there, it's only up at 5, so it's coming back down. Remember that these are smooth curves, no sharp edges, no jagged points. But you should be able to connect this now and give me a decent looking graph. So I'm going to say this side's coming down, this side's going up, it's going to come down to there, and it's going to come down and touch at 3 and go back up. because I know it's even multiplicity and it's just going to touch. And is that necessarily the exact graph? How do I know what's happening between 1 and a half? You know, like it could be off a little bit. But that's a pretty good sketch for only picking 2 points and using the other stuff that we know. On your unit test, you're going to have to graph one of these using these things. Let's do another one. I am so thrilled. I get 48 minutes with you. So excited. But, you know, the point of school is to learn, and now we can learn more, and it's exciting. And everyone's back, except for Nathan, he's still not here. So again, I don't really care if you go in order for these 6 steps, but you got to do everything. So I'm going to go in order again. In behavior, what's the degree of this? Taylor, wake up. 3 and 1. So if you work this out, this would be negative 2x to the 4th. Yes? So what can you tell me about the way the arrows are going to go on this? They're both going to point down, right? So we're going to say as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. I'm okay if on the x and y-intercept part, I don't see a need to restate the x-intercepts, right? Like we're going to do that for part 3. So let's just do the y-intercept here. So the y-intercept is going to be when I plug in 0 for x. So I'm going to get negative 2 times 0 plus 2 times 0 minus 2 to the 3rd. Going to be a big number, huh? Negative 2 times 2 times negative 8 is 32. Is that right? Tried to pick the ones in your homework that weren't too terrible at first, if that makes you feel better. I even got my big giant answer book out and was looking at the graphs to see which ones had somewhat similar. Zeros, which is also x-intercept, so this is like step 1. I'm going to say this is step 2. So step 3 are my zeros. I have a 0 at negative 2, and I have a 0 at 2. This one has a multiplicity of 1, which means it just goes through. And this one has a multiplicity of 3. When we graph this, we're going to have to pay attention to that. Remember, multiplicity of 3 is kind of like the cubic graph where it makes that S shape. So you got to make sure your graph doesn't just go straight through that. You have to kind of show me that, you know, it curves or flattens out. Both of these are going to cross because they're odd. And the idea is if you do this enough, you don't have to write it out every time. Like you're just using those ideas when you're graphing it, right? Like you have to write it out. And what's the maximum number of turning points that this graph has? 3. We already have 32 here. Before I label my graph this time, like before I label my y-axis, this is what I would recommend that you do. Like label your x-axis and think about the numbers you need to pick and make your xy chart before you label your y-axis. Because what if this goes up to like 100? I don't want to make my graph go by tens and then not have enough room on my graph. So if I did this one, it's going to cross at negative 2 and positive 2. So we need to pick maybe like negative 1 and 1 and see what's happening. And then we can figure out what we want to do on our y-axis. Does that make sense of maybe why you should pick your points first? So I'm going to pick negative 1 and positive 1. We already know the y-intercept, so we don't need to pick 0. We already know it's up at 32. And use a calculator by all means. Like, hopefully you have one or can get one to use so you're not making mistakes on this. But if we plug negative 1 in here, I'm going to do my work up here. I'm going to get negative 2 times 1 times negative 3 to the third. Yikes. That's going to be negative 2 times negative 27, which I think is 54. Did you get that, Sawyer? And if I plug 1 in there, I get negative 2 times 3 times negative 1 to the third, which is negative 1. So is that 6? Did you get 6? So maybe we have 32 and 54. Maybe you want to go by tens on this. I don't care how you label it. You just got to fit the stuff on there. Definitely not smart to go by ones on this. You don't want to go up to 54. So I'm going to go by tens based on the numbers that I got. And that's what you have to think about. So 10, 20, 30, 40, 50, 60. And label something there, right? 10, 20. Negative 10, 20, 30, 40. So at 0, I know it's up here at 32, which is like right here. At negative 1, it's at 54. 10, 20, 30, 40, 54. And at positive 1, it's at 6, which I'm going to say is about right there. So get your points labeled, and before you connect them, I want you to pay attention here so we can talk about this multiplicity part. We know that both arrows point down, which is a good thing, since all of our points are above here, so it's good that they both point down to show that they cross. But the multiplicity matters here. Negative 2 has a multiplicity of 1, so it's not really going to do anything. It's just going to kind of come through, and sometimes I like just go down like this. But a multiplicity of 3, think about that x cubed graph, how it kind of makes that S shape. It's going to come down here, and it's going to kind of, I don't even know how to say, flatten out on the x-axis. So like I want to see that you're not just drawing it straight through. I want to see that you're kind of making that little curve on a multiplicity of 3. And this is a decent amount of work to do, but I'm telling you, if we didn't have these things, you would be picking a lot more points. I don't know if you remember in Algebra 2, before you learned in behavior and stuff like this, you just had to make an XY chart with like 10 numbers on it sometimes, which is awful. We just made an XY chart with 2 numbers in there. Who loves math? What about the next one? How does it look different than the 2 that we did? Because these are nice. They're already factored out for us, right? And we don't necessarily have to, so I can stop and let you start some here. But I gave you, I think, one like this on your homework. And even in the directions on this, it says, like, do the 6 steps, blah, blah, blah. And it says, hint, you may need to factor first. Because we want it in those parentheses. And so they're going to give you something like this that you could factor. Could I factor an x out of this? And I'd be left with x squared plus x minus 12. And then could I factor what's left over there in the middle and FOIL that? And I would say what multiplies to give me negative 12, that subtracts to give me positive 1, positive 4, negative 3. And then now does that look like the 2 that we just did? And so now I'm not going to bore you. I'm going to let you actually get started on your homework. But now you can go through and you can say it's degree 3, you could say the in behavior, you could say there's 3 zeros, they all have a multiplicity of 1, and you could do all that. But this is kind of leading us into, at some point, we're going to be dealing with stuff that aren't factorable, but of how to deal with those. Let's see how many homework problems I use. $69, $70, $77, $81, $95. Consider it. It's 5 problems that you have to grab. Alright, but saying the in behavior and saying the number of turning points does not count as one problem. No, I did it. All the homework, yesterday's homework, there were A, B, D, E. There were 4 steps on yesterday's homework, and we're really, and that was one problem. Well, this is why this is college, now. This is 5-1, day 3. I'm gonna say I'm not gonna give graph paper for this because your axis, like you're gonna have to do your axis different ways, and so just draw your own graphs on here. If you have your own graph paper, that's fine. But my little graph paper, I feel like is not gonna be great for this because you're gonna be making your axis go by different things. It's not that bad to do, and you should be able to get at least one done before you go. But you know, you haven't had terrible homework.